Hello everyone. In previous video, we had discussed FCFS, first come, first serve. And we noticed how the service it will be given in the sequence. As the request it is coming, the service it will be given in the same sequence. And seek time for this one is 642. Then we have to continue with the next algorithm here. That is shortest seek time first. The name itself, it is giving the identity. In case of the FCFS, irrespective of the timing and all, how the sequence it will be coming by default, the sequence how it will comes like that it will goes on giving the service. But whereas in case of the SSTF, that is the shortest seek time first, here it cannot go for the sequence. Initially, read and write head, it is in the 50th position. Here we have a read and write head. It will be having in the 50th position. So from there, which is the nearest file? For that, it will be giving the service first. Means wherever there is a read write head from that position, which file it is very much near to that, it will goes on giving the service in the sequence here. So here we have a initially 50, it is in the initial position, and 52 where first file service it will use 43, which is very much near to 50. And again from 43, which is the nearest, 24 is the nearest, for that it will be giving the service. Again from 24, it will goes to the 16, 16 which is very nearest to that of the 24 among all the remaining. And again for 16, here we have a 82 nearest among all the rest of files. And again here we have a 140 which is near to the 82 among all the remaining. And 170 is nearest to the 140, and 199 it is nearest to the 190, it is nearest to the 170. So in this way, which is very much near to that of the current position of read write head, it will goes on giving the service. So 50 to 43 means 50 minus 43 it is, and 43 to 24 means 43 minus 24, and 24 to 16 means 24 minus 16. So that distance, here we are calculating the distance of each and every service, and sum of all these distance that it will give the total seek time. So here we have a total seek time, it is a 208, which is very less comparing to that of the previous algorithm. That is the first come, first serve. In first come, first serve, you can notice the service initially it will be started from 50, 82, and again directly it will goes to 170. 172, again 43 it will comes. Again it will goes to 150. So here we have a back and forth rotation of the read write head. It will be more number of cylinders it will be crossing. That's what it will take some maximum seek time. That is a 642. But whereas in case of SSTF, it will be optimal and efficient. It will take some minimum seek time. Then we have to go for the next one here. That is the scan algorithm. It is also called as the elevator algorithm. As a name itself, it is giving the identity scanning. It will be scanning the entire disk back and forth. Here we have a one time it will be scanning from its initial position to the rightmost position, and again from rightmost position to the leftmost. On the way, which are the services required, it will goes on giving the, which are the requests are there. For those, it will goes on giving the service here. So initially here we have a 50. From 50 to 82, it will give us a service. Again, from there, it will be going to the 142 and 170, and then 190 it will take. So again from 190, it will comes to the 50 service it will be giving. 190 actually here in case of the scan, not only up to 190, even though 190 it is the last service, it will goes to the dead end of this sequence here. Means what is the track it will be having, last track it will be visiting. Here we have a leftmost track, it is a 0 position, and rightmost track it will be 199. Up to 199 it will goes, and from 199 again it will be taking its reverse path. So here from 199 to all other requests it will goes on giving up to the last one. The last service it will be of the 16 here. That's what here very simple calculation we can take. Initially it is in the 50, and rightmost position it is 199. So 199 minus 50, that it will give the distance from here to here. Again from 192 it will takes here 16. So here we have a 190 minus 16 that it will give the distance from the rightmost position to the last service. Here it will be giving the last service. If last service up to 0 means it will take up to 0. So now for this we have a total number of rotations. Total number of the disk transferred will be 332 here comparing to that of the previous algorithm. Again it is more. But when it is compared with the first come first serve, it will be less efficient. First in first serve, then from that it will be efficient, and the shortest seek time that it will be more efficient comparing to that of the scan. Comparing to that one, it may be a little bit inefficient. The next here, one thing you have to notice, the service is giving in back and forth, both the direction. Here we can notice the service it will goes on giving in the right side, rightmost position. And from there again, it will comes by giving the service in the reverse position. So it will be giving the service. It will be giving the service for the request in the back as well as forth in both the direction. That's what it is the scan. So one more algorithm is there, that is the C-scan. Same example it is taken, and in C-scan it is same as the scan only, no any difference. Only the genuine difference is in case of the scan we have a back and forth service, but in case of the C-scan it is only in one direction service. That is only in the forward direction it will be giving the service. Look here, 52, 82 and 142, 150, and then last it will comes to 199, and from 199 directly it will comes to the 0th position. Again from 0th position in the same direction, remaining files it will be servicing here. So here we have a request on the way up to rightmost position. Again from rightmost position, when it is coming to the left, it cannot give any of the service. Directly it will comes to the initial position, and from there it goes on giving the service for the remaining files. This is the C-scan, only in one direction it is. That's what initial position 50 and up to 199, rightmost position. 199 minus 50, that difference it will take. That is the distance. Plus, again here we have a 199 to, it will take 0 because it will comes to the leftmost position. That is the first track. 199 minus 0. Plus, again, from here, 0th to it will be giving remaining file services. That is up to 43. That's what 43 minus 0. So sum of all these that it will be of the 391. So here we have a rotation time, that seek time it will be of the 391. For previous one it was 332. So comparatively it is inefficient comparing to that of the previous scan. Scan is efficient than C-scan. And then next here we have a look. One more algorithm, it is the look here. It is also same as the scan only, but the difference is same as the scan. Here the difference, not C-scan, it is same as the scan. So here we have a both the side service it is giving. That's what it is the look. If it is giving service only for one side, then it will be C look here. So first here we have a difference from scan to look means. In case of the look scan, it will be going to the rightmost position. That is last service it is up to 190. But in case of scan, it will be moving up to 199. When it is coming to the back, that is leftmost position, it will comes up to 0. That is a scan. But in case of the look, here it is not going up to the dead end, up to the last service. Last service it is 190. Suppose last service it was 170. Only up to that point it will take, and from that point it will be reversing back here. Only up to the last service it will be providing. That's what here we can notice. It is 190 minus 50. In case of the scan, it was 199 minus 50 because rightmost position it was taken. Here it is 190 minus 50 plus. Again, here we have a back and forth, forward direction, backward direction. Both the side it is giving the service. Now here we have a 190 minus 16 it is. This is the distance from left to right, and this is the distance from right to left. So total number of cylinders are crossed are 314. That is the seek time, it will be taken as a 314 here. And one more we have a C look. C look, it is same as a look only. How the difference between scan and C scan it is taken. In the similar way, we have a look as well as C look. In case of the look, it is taken the service in both the direction, back as well as forth. But whereas in C look, it is giving service only for the forward direction request. That is 50. 50 to all the files it will be servicing here. And last service it is 190. From 190 it will be reverting back. And when it will be reverting back, the first service, it will be 16. It cannot go up to 0. But whereas in case of the C scan, it is going up to 0 here. Now here it is a 16. And from here again, remaining file service it will gives. So total seek time taken for this one, it is 341 here. 341. So C look as well as look. Here it is 341 and previously it was 314. So look, it will be efficient comparing to that of the C look. And like that only here we have a C scan, it is 391, whereas scan it will be 332. That it will be efficient. Means scan and look are efficient than that of the C scan as well as C look here. Because in case of the C scan and C look, only in one direction service, not both the direction. But in scan and look, it is both the direction. Among all the algorithms, the best optimal solution, efficient algorithm is the SSTF. That is the shortest seek time first. And the most inefficient, maximum time taken algorithm is the FCFS. That is with the 642. Same example we have taken for all the algorithms here, so that we can compare exactly which one it is efficient and which is non-efficient. FCFS, it is inefficient totally, and SSTF, it is the most efficient algorithm, whereas the remaining look as well as C look, they will be of the moderate, in between they will be coming. This is all about all the scheduling algorithms. I hope it is clear to you. Thank you for watching.